me okay? All right. I love when Canva doesn't cooperate, but if you don't know me, my name is Kaleb Garner. I am a full-stack developer based here in Addison, Texas. But today we are going to be talking about web performance. In today's technology ecosystem, there's a great need for speed. I'm not apologizing for that joke, but there is a need for speed when it comes to our web applications being as efficient as possible. And if you don't believe me, I have some statistics that show exactly why we should be prioritizing web performance in our applications. First one, sites that load in 1 second have conversion rates that are 3 times higher than sites that load in 5 seconds. Going off of that, bounce rates increase by 123% if a site takes longer than 1 second to load. I think this last one kind of ties in exactly why we should be really prioritizing this. Websites that load slowly cost retailers $2.6 billion or US dollars in sales each year. I think these statistics paint a clear picture of why we should be prioritizing web performance. But today I want to talk about how our framework's solving web performance. Today we're going to be looking at 3 different buckets that these frameworks are attacking in order to improve web performance. 3 I'm going to talk about is rendering, hydration, and deliverability. And we're going to look at these advances that these frameworks are taking in order to solve these 3 issues. Starting, of course, with rendering. In the traditional sense, you saw 2 different rendering models. You either had, and which caused our clients to have 2 different problems. They're either waiting on each individual page in a multi-page application, or they're waiting a longer time for that first page to load in a single page application. With these new advancements, we're seeing a different change. We're seeing integrations and combinations of different models in order to render these websites. So we're taking the best of both worlds in order to increase the performance. So the first area we're talking about is React and React server components. So in this example, we're going to look at your normal e-commerce website. You know, you go to your Amazons, you go to whatever you may picture. You have a product grid, and then you have your interactable components. You're going to have an add to cart button and maybe a stock availability that shows you real time how much stock is left. When we have React server components, we're going to be taking these pieces of our page that the clients only need to see. They're not going to be interacting with, and we're allowing that to be rendered on the server. We're allowing the server to compile this and create an HTML page that gets sent directly to our clients with this React server components. And you might ask, well, why don't we do the whole page like that? Well, you have to think about the interactable pieces. We still have to compile the event listeners in the browsers. We still have to compile the real-time state management in the browser. So the interactive pieces we're leaving on the client to render, but these pieces that the clients are only going to be looking at, we can use React server components. A thing that ties this together is React Suspense. Suspense allows us to render these components on the server and still have a space that says, hey, you're going to get a component, it's just not here just yet. It's allowing us to have this state and shows a placeholder while these RSCs are still loading on the back end. So the server handles the heavy lifting, client handles interactivity, and Suspense keeps perceived performance high. Second area, and this ties in closely with RSCs, but Next.js streaming SSR. In traditional sense, you often see a blank page. You'll see a blank page while these components are loading, and then you'll see the entire page load all at once. When we are able to stream these, or stream SSR, or server-side rendering, we're able to stream these components to the front end as they finish. So we're no longer waiting for all the components to finish. We're telling Next, hey, when this is done rendering, you can send it to the front end. So we're no longer waiting for these heavier components like the products or any component that's going to be heavier. It won't hold up something that renders much faster, like a header or a sidebar or all these other elements. So we're no longer blocking the rest of the components and have components waiting ready to be sent to the client. We're able to stream these components to the client whenever they are finished. And third is Remix. So this is a little more hands-on. So in this example, we have a dashboard, and you'll see on the top left, we have the file structure for this dashboard. You'll see we have a dashboard component, the JSX, but we also have a dashboard folder. In this remix, we're able to, or they're recognized as the exact same component. It understands that this folder is talking about the dashboard component. And within the dashboard folder, we have these nested routes where you can put whatever other components you want in here, whether it's sales or any other dashboard you want. And when we navigate to /dashboard, we'll have the dashboard component. This will be your layout, but within this layout, you will have an outlet. This outlet is a place that holds these nested routes and nested components. So the big part of this, when you navigate to dashboard.sales, you'll see the sales component is in there, but here's the best part. This is why this is important for rendering. The dashboard doesn't reload. In a normal component, this whole component would have to reload. It would have to figure out the parent and it would have to figure out the child. But in this instance, only the sales part reloads. So we're only changing the page when a component changes. We're able to keep the state that stays the same. So why do we talk about rendering? And what direction are these frameworks going? Well, we're seeing that instead of having this hard state, you're either all in on SSR or client side or server side, we're mixing the best of both worlds. We're able to get these hybrid approaches in order to get the best experience out of our frameworks. Now, the next area I want to talk about is smart hydration. This is when our HTML becomes interactive. And in this case, this can cause performance delays on the front end because we're having to wait for all the interactivity to be resolved on the front end before the users can actually interact with our page. And we're going to see exactly what these frameworks are doing to allow our users to not be blocked by the other interactive components, but be able to interact with our page faster. And I'm not skipping Astro, I promise. So the first area is Astro Island architecture. So obviously we have our static components. In this example, it's a blog page. Our blog content's not going to change. So this static HTML is sent to our client immediately. But our interactive components, our search bars, our comment section, things that need to be hydrated and need to have interactivity are going to have these slots called islands. On islands, we have these on the front end, and these are going to be placeholders until these interactive pieces are fully hydrated and able to be interacted with from the client. So our static HTML gets sent to the client as quickly as possible while still not hindering our site by removing the interactivity. The interactive pieces come later, but we're getting content to the client as quickly as possible. Second area. This is a fun one. I like this one. Quick resumability. So when we have a traditional site, on the server, when we think of server-side rendering, you think it plays through the logic of the site. We get the state management, we get the event listers on the server, and it just gets sent to the client. Well, the client also has to replay all of that logic. It has to determine that logic by itself because of all those interactive pieces. What does Quick allow us to do? Quick allows us to serialize this app's state, the componentry, the event listers, everything that makes this app interactive. We're able to pause it at that state, send that in a serialized version to the front end to the client, and the client resumes this status on the client. So instead of having to replay this logic on our client side as well as the server, the client just continues on like nothing, like it had done it itself. And you think about a video game. Has anyone been playing Silksong? A couple? Okay. So if I would hate the game if I had to leave and I just paused, left, and restart from the very beginning when I came back. I would never finish it. But since we're able to stop, save, and come back to that same state, that's what makes the game finishable. And this is what Quick is doing. We're pausing that state and not replaying it from the beginning. On the client side, we're able to resume from that point. And lastly, Vue.js lazy hydration. I'm going to hurt a lot of y'all's feelings with this. Sometimes we make really amazing components. You put all of your work, you spend like a week's worth of dev hours building this amazing interactive component, and the users are just going to skip over it. The users are going to navigate off of the page, or they're going to go to a different sidebar or a different link before they even see this component. But the truth is that component still hinders the page speed. That component is still going to hold back how fast the clients are able to interact with their page. So what does Vue let us do? In lazy hydration, these components only hydrate when they absolutely need to. When they come into the viewport or they're interacted with, they will not hydrate until the client absolutely has to have it hydrate, until they have to interact with it. So what are we seeing? With these different approaches, we're seeing the priority to get interactive client as quickly as possible. We're not rendering or not hydrating everything all up front. We're choosing, or these frameworks are choosing to hydrate at proper times when it's absolutely needed and as quickly as possible. We're not blocking anything with our hydration techniques. And lastly, smart delivery. We've seen, and I'll get into this a little bit with the Astro section in here, but when we deliver our apps, a lot of the time there is bloat. There is unnecessary JavaScript that the client's not even going to use on the client, or the client's not even going to use in the finished product with the end users interacting with it. So how do we prioritize and ship less to or how do we smartly deliver our apps to our clients? Well, the first area is Next.js and NextScript. NextScript allows us to decide and prioritize when our script should be loaded in our site. And we have 3 different states that we look at. Before interactive, that's our top priority. These are the scripts that we absolutely need on our site. That's going to be loaded before any hydration. After interactive, it's loaded after hydration has started. We're already going to start making the site interactive before we even start loading these scripts. And lastly, lazy on load. It is loaded during idle time. Our app is completely rendered. It is hydrated. We're going to wait to render this until it is idle. We're not rendering anything else or hydrating anything else on our page. And that can be or whatever third-party scripts that you're choosing to prioritize. That's up to you, and that's up to what your page actually needs, instead of being forced to load all these scripts up front and hinder the page. Now, second area is Astro. So other frameworks, like I said, send a lot of bloat. By default, they're going to send JavaScript to the client. And a lot of the time, the client's not going to use this JavaScript, or is going to provide extra bloat and increase that payload, making the deliverability to our app, or hindering the deliverability to our app. Astro changed that mindset. Astro said that we're not sending JavaScript to the client by a default. So instead of other frameworks asking, what can we strip away to make this deliverability faster, Astro is saying, what do we need to add that's absolutely necessary for our page? Making a priority for minimalism as we're sending these payloads to our client, and making sure that it's only delivering what is absolutely necessary. And last, we were talking about Nux, Nitro and Edge. So Nitro is Nux's new server engine, and instead of relying directly on Node.js servers, Nux can now be run on any environment: serverless, Edge runtimes, workers, and more. So now we have the capability to bring Nux apps closer to our clients and where our users are living. Now, I know what you're saying, Caleb, this is cheating, this is DevOps. But I want to paint the priority that as a default, Nux is giving us that priority and the advantage of having the ability to host these on Edge runtimes. That's at the framework level as a priority. We're not over-configuring, we're not having to specialize our app to be run on the Edge runtimes, but Nux as a default is prioritizing hosting our apps closer to our users. So why did I talk about deliverability? The truth is that even if our hydration and our rendering is spot on, completely optimized, delivering the apps is going to be the advantage that we take. That takes our app to the next level for delivering these sites to our clients. So 3 core areas: smart rendering, smart hydration, and smart delivery. We've seen these 3 big bottlenecks that have been in the industry for a very long time, but we're seeing a shift in the mindset of these frameworks. We're no longer seeing a battle over which way to write server-side clients out. We're not seeing this fight anymore. We're seeing an agreement and kind of a compilation of what is the right method for these sites to actually deliver our apps in an efficient way. And that's a big takeaway I want you to take from this talk. It's no longer about what frameworks are the best or what frameworks are fastest. It is these mindsets and these core areas that each of these frameworks are attacking in a different way, that as developers we can continue and push forward and think about these mindsets and think about facing these bottlenecks as we build these sites that are going to bring our apps from building in the past way to building our apps in the future. And that is the true way that we face this need for speed. Thank you. I have a little extra time, so wow. Hi, guys. So I have a little extra time, so this is a QR code to my LinkedIn if you want to send me a connection. It has my website on there, a little bit of extra information about me. I forgot I just threw a QR code up there without actually describing what it is. So yeah, that's a QR code. I would love to connect with you. obviously, you can feel free to connect with me after. We can ask questions. We have lunch after this. I'm very excited about lunch. I'm very hungry. But yeah, I just wanted to thank all of you for attending the talk, and huge thank you to CYC and everyone who made this possible in general. Can we give a round of applause for everyone? What this community is doing and what this conference does for the community as a whole, I've seen so many people fly into some amazing locations. It is such an amazing opportunity, so I just wanted to put that out there while I have some extra time. But thank you all for listening to my talk here. I really appreciate everyone who made it out, so that is all.